All right, so let's talk about Unit 2 FRQB. And this one, you're given a graph of a function and a graph of its derivative. And notice they are the same, representing the same function. It's just one is the function itself, one is the derivative. And you're asked several questions. So the first is to find the average rate of change for the interval from -5 to 5. So remember AROC would be f of 5 minus f of -5. Sorry, screen jumped there. Over 5 minus -5. So I look at the graph and I say, okay, f of 5 is 9, f of -5 is 3, and that's all over 10. So then that would be 6 over 10, or 3/5. And then it says, how many values in the interval from -5 to 5 does the instantaneous rate of change equal the average rate of change over that interval? So the average rate of change was 3/5. So we're looking for how many places where the derivative equals 3/5. Now that would be hard to tell from the graph of f, because we'd have to like estimate with our eyes where a slope of a tangent line would have a slope would be 3/5. But they gave us the graph of f prime, which is the derivative values. So if you look on that graph, it looks like right here-ish and right here-ish are two places where that derivative equals 3/5. So I would say it happens at two x values. All right, part B. Write an equation for a line tangent to the graph at x equals 2. So we need a point. So for that, we need 2 comma f of 2. And f of 2 is 6. And then we need a slope. And for slope, it would be f prime of 2. So we look at the graph of f prime. F prime of 2 is -2. So then the equation of my line was that. Now, part C. And I may have reversed the order on these, but I think it's right. I think this is part C. So for each the limit as x approaches -1, f of x minus f of -1, x minus -1, and the one with 3 in it, find a value or give a reason why it does not exist. So I want you to keep in mind this and this are both indicative of the A definition of the AROC, sorry, of the IROC. So this is literally talking about a derivative. So the first one is talking about the derivative at -1. So they want to know f prime of -1. So if you look at the graph, f prime of -1 is 4. Now don't let it throw you that there's a sudden change in slope on the graph of f prime. What we would be worried about is a sudden change in slope on the graph of f. And keep in mind right there, sorry, not there. Oops, undo. Right there, there's not a sudden change in slope. The slope happens to be x equals 4. So that is 4. And then f prime of 3, there you see the slope is two different things from either side, and it's not defined at 3 at all. So that one is undefined. And if you wanted to give a reason, you could say there's a discontinuity on the graph of f prime, and f prime of 3 doesn't exist. Or you could say there's a sudden change in slope on the graph of f at x equals 3. And now part D. I feel like if you've watched the other FRQ videos, you're probably familiar with how this one's going to go. It's been several of the same type of problem. So they want to find g prime of 4. G is defined as this. So I'm going to use proper rules to take the derivative, and that'll be, in this case, the product rule. So first times the derivative of the second plus second times the derivative of the first. And then I want to find g prime of 4, so I'm going to plug 4 in. And again, I don't remember if this was a calculator part or a non-calculator part. If it was a non-calculator part, you could just leave ln of 4 as ln of 4, and that would be fine. That's a prime there. And then I look at my graphs. F of 4, 6. F prime of 4 is 3. So then basically it's 3 halves plus 3 ln of 4.